Your influence in space. Introduction. Your influence in space primarily discusses the concept of space preparation. In short, your light extends to the edge of the universe in at least one or more reference frames. We begin our journey by looking at the evolution of the human senses. We see that some senses come from evolving on Earth, and some come from evolving around the Sun. The Doppler shift is examined and shows us how our light or influence can stretch and crunch, depending on relative motions. Our journey then takes another look at gravity. Perhaps the force of gravity comes from planets acting as shields or blocking an interstellar star pressure, rather than them being a source of attraction. However, ultimately, it is all waves, and the nature of reality may be an overlapping of the electromagnetic energies. We define the light state of the universe and introduce the liquid light state universe. The senses. Not only did we evolve on Earth, which revolves around the Sun, but we also evolved in an expanding universe, hence, our sense of time. Here we will take a look at the human senses. We will explore why we even have senses and where they first came from. It is important to first explore these concepts because they are crucial for understanding our sense of space and time and the concept of space preparation. Darwin's theory of evolution. Most of us are familiar with Darwin's theory of evolution. However, let's do a quick recap. It basically states that all life is related and extends from a common ancestor. Over long periods of time, these animals change to be better suited for their environment. Sensory evolution. First, it is important to discuss why beings even have senses, what they can sense with them, and why they may be considered beneficial for survival. We could go into much more detail on each topic, but considering this is simply a stepping stone for understanding space preparation, we will keep this simple. While we discuss, keep in the back of your mind that physical existence is a combination of light and solid. More specifically, light creates the solids. Photons could be considered like electrons moving at the speed of light from atom to atom. However, different combinations of light create the physical world, and these combinations may fabricate themselves to be any particle in existence. In short, matter is composed of light. Evolving on Earth. Animals have been said to have evolved on Earth. This statement is a rather simple system when compared to the greater picture. Animals did evolve on Earth, yet they also evolved in a solar system. To take that one step further, evolution occurred within an expanding universe. For the senses of smell and taste, we have organs that detect physical particles. The organs in this case would be the nose and tongue. They send electrical signals to our brains and let our bodies know if action is needed or not. They can tell us if something is edible or not. If something tastes or smells bad, it is most likely not edible. They can warn our bodies of approaching dangers like fire. The scent of smoke is strongly recognizable. You could say that these sensory organs are tuned to what would allow the species to survive and reproduce. The case for reproduction is clear with pheromones. These senses have been designed through evolution on Earth to detect physical molecules. The nose and tongue are detecting molecules that are made of matter. Now consider the sense of hearing. Again, you are detecting physical matter, but this time it is in the form of pressure waves. Pressure waves create the sounds you hear. The range of hearing is directly related to the frequency of a being's vocal cords. This is why we cannot perceive the highest pitches of a mouse and the lowest pitches of an elephant. Mice are tuned to a much higher frequency of sound, and elephants are tuned to a much lower frequency. However, the main point is that this sense is also detecting physical matter. The sense of touch is somewhat unique because it can detect molecules and light. Your sense of feeling comes from physically interacting with objects. You know that contact has been made because magnetic energy in your molecules is being directly interfered with by the molecules of whatever you are touching. This is obvious. What might not be so obvious is that you can feel if something is hot or cold. The implications of this are much grander than you may think. Your sense of touch can actually sense temperature differences without contact. You could say that human skin has the ability to detect infrared energy. It may be safe to assume that it may also be able to detect slightly shorter and slightly longer wavelengths. This means that you can essentially see with your sense of feeling. In the simplest terms, Your skin can sense heat with no physical contact and only that of electromagnetic energy. The sense of sound, taste, and smell all come from directly evolving on Earth. Feel may be the first sense that gives us the clue of a sun. Evolving in a solar system. Not only did we evolve on Earth, but we also evolved in a solar system. For light, the organ would be the eyeball, and it detects electromagnetism. Light comes in many wavelengths, and similar to sound, eyes are best tuned to the environment in which they live. Again, to keep this moving towards space preparation and not be too sidetracked, we will keep this section short. The human vision is focused around the color yellow, which is the maximum wavelength of output emitted by the sun. The implications of this may be much grander than we realize. The senses of sound, touch, taste, and smell all came from evolving on Earth. Here we see the first trace of a sensory organ's evolutionary influence coming from space. Eyes detect electromagnetic waves that come from space. To keep it simple, the sun's light hits the Earth and then bounces around in many visible wavelengths. Similar to the ear's form of acoustic wave detection, the eye has a limited range of electromagnetic frequencies in which it may gather information. There are many wavelengths that the eye cannot sense. The eye cannot sense waves that are shorter than blue or longer than red. Our eyes only see an extremely small portion of the electromagnetic spectrum when compared to all the possibilities in existence. The point, and I stress this point, is that light waves exist that we cannot detect, and the ones we do are beneficial for surviving the current moment. Evolving in an expanding universe. The sense of time exists and is a result of evolving in an expanding universe where light is able to move freely from atom to atom. The sense of time may be extremely hard to measure. Sure, you can measure how far light travels and use a pendulum, but all that varies according to your relativistic velocity. It could be safe to say that similar waves like those from short to long of the electromagnetic and acoustic frequencies exist in time as well, and we have the ability to detect the one that is most beneficial for surviving the current moment. Now for time, this may be an obvious statement, but it is most beneficial to sense the now and not the past or the future for your average animal. Every sense is ultimately filtered by your brain to give you a way to best interact with the environment. The past is solid and exists, yet we cannot physically see it. The present exists and we can see it. The future will be solid and it will exist. This implies that all future may be as solid as our past. Our sense of time is tuned to the now because it is what is most beneficial for surviving the current moment and producing offspring. Limitations of physical mediums. There are limitations to the mediums in which our senses are tuned. We are now shifting over to talk about the accuracy of our senses to the physical environment. From the last section, we saw that each sense has a threshold, a range of frequencies in which it may gather information. We also see that each sense is tuned to a certain substance or medium. For example, ears are tuned to acoustic waves, which vibrate through physical matter. Typically, the medium is air. However, you can put your ear on a desk and tap the desk, and now you are listening through a desk which is made of a solid. Now the desk is the medium. In both cases, the medium determines the accuracy of your sense of choice. Accuracy, in this case, refers in your ability to locate the signal that you are searching for. In other words, where is the object you are listening for? For sound waves, the denser the medium is, the faster the wave will travel. The faster the wave travels, the more accurately you may predict the location of the source because there is less chance that it has moved. Very quickly and for fun, could there exist a density to where the velocity of sound is greater than that of the speed of light? It is important to recognize that sound has a maximum velocity at which it can travel through any medium, and it is generally governed by the density of the material. The basic equation is as followed. The speed of sound is equal to the square root of Bulk's modulus divided by density. You can clearly see that the speed of sound varies through different mediums. Let's do a quick thought experiment. Imagine if we did not evolve with eyes and only had ears. Our entire world and understanding of space and time would be solely based off sounds. We might think that the speed of sound is the fastest speed available as far as communications are concerned. The perceived locations of an object would be directly related to the speed at which it takes sound to travel. acoustic waves would be the source of information exchange within our known universe. We would not know of stars and light because we would not have evolved with tools necessary to do so. However, as humans, and having evolved with electromagnetic detection abilities, we know that light travels much faster than sound. For example, we can see a lightning strike well before we hear the thunder. Knowing this, we think it's completely silly or even ridiculous to consider the speed of sound as the ultimate barrier as far as physical matter moving through space. At least we are smarter than the worms. Understanding our senses is crucial for understanding our universe. Consider the earthworm in politics. The worm lives all day in the dirt and is extremely efficient at what it does. It eats and poops dirt. If you were to ask a worm about human politics, it would be clueless. It would not know if it was a Democrat or a Republican. The worm would not have a clue. This is because of two main reasons. The first is quite obvious. The earthworm has a small brain. The second is that the earthworm does not need to understand human politics. For that reason, it did not evolve with the tools necessary to do so. Remember, senses help us live in the now and reproduce. Although human politics may influence a worm's habitat through farming and other secondary means, the worm will never be able to fully comprehend what is happening solely because it does not have the senses to be able to. Will a worm ever truly understand human politics? The answer is no. Worms do not have the physical ability to comprehend such concepts. The worm is not physically or mentally evolved enough to understand with the same capability as a human as to what it means to be alive in the universe. The worm has no knowledge of other planets, comets, black holes, and etc. Those parts of existence have no influence on the worm's day-to-day survival. But we are not that smart. Compare humans to the earthworm. We are bounds and leaps ahead of them as far as technological advancements and knowledge of the stars is concerned. We can make art, complicated communications, build telescopes, and decipher the stars. But how smart are we really when compared to the most advanced life forms in existence? The Earth has been around for about 4.5 billion years, and humans roughly appeared 100,000 years ago. That's not really that much time when compared to the age of the Earth, and especially when compared to the age of the universe, which is estimated to be about 14 billion years old. There could be life forms that have been around for 200,000 years, or even a billion years. These life forms could potentially have much more developed senses than we do. Humans, to these theoretical aliens, could be just as smart as earthworms are to us. Light is the source of information exchange. The fastest source of information exchange when it comes to natural evolutionary senses is electromagnetism. Electromagnetism is light. The speed of light may seem very fast. It may seem almost instant. You can have a conversation with someone on the other side of the planet with little to no delay. This comes down to perception. Light appears to move fast to humans, but to the theoretical alien that may have more developed senses than we do, light may move extremely slow. The thought of communicating through electromagnetism may be equivalent to talking to someone with two cups tied together with a string. To give an example for our humanly understanding, imagine that this being can see and travel through wormholes with their natural body and no technology, just as easy as we can see the stars at night. The universe's greatest magic trick. Matter can travel faster than light, but it will not look like it. It is the universe's greatest magic trick. Consider the magician. They use lights and trickery to create an illusion. The reason why the tricks work is because they make you believe something is happening when it is not. They will make a sound or show an image. People then think something is somewhere because they already hear it. However, in reality, it is already in their back pocket. The same is true for light within the universe. The Doppler effect. The Doppler shift can be seen in many different waveforms. Again, let's consider sound waves for this example. Imagine a simple tone. Let's say it's a generic 100 units in wavelength. Now take the source of sound and give it a velocity in a direction that is either moving towards or away from you. You will notice that the wavelength will change accordingly. When compared to a stationary object, objects traveling towards you will have a higher frequency, and objects moving away from you will have a lower frequency. This is where things get a little tricky. Let's say the object is a train. When you are on the train, you really won't notice anything. The sound will be a constant hum from the engine or wheels rolling on the tracks. Now let's say you are on the side of the tracks and the train comes racing by. The sound of the train will change as it passes. it will change from short waves while it's coming towards you, then being shifted to long waves while it's moving away from you. This is an example of the Doppler shift that may be seen in our day-to-day life. All wave types undergo a Doppler shift. The effect of the Doppler shift is directly related to the velocity and location of the wave source. In the previous example, the source would have been the train. The Doppler effect is also true for electromagnetism. The electromagnetic spectrum may be broken down into many different wave types. However, for this section, it is important to note that all waves, X-rays, visible light, radio waves, gamma waves, and etc., are all forms of electromagnetic waves. They are composed of the same forces that we physically see. The only difference is the frequency, or wavelength. The appearance of an electromagnetic wave is directly related to the original source of the wave and its velocity when compared to the observer. Let's now look at a simple example for light. Imagine a yellow light. It sits somewhere stationary in space. Now the light decides to come racing towards you at the speeds relative to the speed of light. As the object comes near, the light waves begin to crunch. The light therefore has a higher frequency and looks bluer. As the light passes, you will notice that it turns from blue to yellow to red. The light is now traveling away from you, so the wavelengths have been stretched. It now has a longer frequency because it is moving away. Another important factor is that the speed of light is constant no matter how fast you are moving. This means that the apparent distances the light has traveled may vary based on the observer. Let's now imagine we have a UFO that can accelerate at infinite velocity. Imagine we shine a beam of light for 1 second. Let's now generalize on the relative distances the light has traveled based on the speed of the observer. For this, we'll need 4 observers. Observer 0 is stationary on Earth, 0c. Observer 1 is flying at the speed of light, 1c. Observer 2 is flying at 2 times the speed of light, and observer infinity is flying at infinite velocity. A quick side. The theory of relativity says that nothing can travel faster than the speed of light. We are saying that is an illusion created by the permeation of light within space and human consciousness. The trick. Ask yourself, how can anything ever look like it's going faster than light if light is the most advanced source of information exchange for human consciousness? The relative time dilations are still of an important factor because that is how matter acts when it's in motion. However, what would 2 photons accelerating at light speed in the same direction look like to another? They may appear frozen in space, like matter. Consider a particle accelerating at light speed. Try to imagine the light being emitted in front and behind. Here's a quick thought experiment to help you visualize the scenario. The force of gravity is 9.8 meters per second squared for Earth. In order to lift off with a rocket, your acceleration needs to be greater than 9.8 meters per second squared. If it is less, you wouldn't take off, but you would weigh less. However, at exactly 9.8 meters per second squared, you will neither lift or have weight. That would be the same effect as a photon being emitted from a particle accelerating at light speed. They would either be stuck in the direction of travel and appear to be mass, or emitted in the reverse direction. So is there a difference between light and matter, or is that just a result of your relative frame of motion? Is the matter we manifest with a result of light speed acceleration? Let's go back to the example of the UFO and yellow light. And while we are doing this, let's relate the amount of energy the wave has with the distance it has traveled. We will now shine a light for 1 second of time. Observer 0, the person on Earth not moving, experiences the light has traveled 1c and looks yellow. Observer 1, the person traveling at 1 time the speed of light, sees the light has traveled 2c and looks redder. The wavelength is longer and the standing energy associated with frequency is less. Observer 2, the person traveling at 2 times the speed of light, sees that the light has traveled 3c and is even more stretched. The light may now be in the radio waveform and its frequency even less. Observer 3, the person at infinite velocity, sees that the light has still traveled in front of them. It is at a distance of infinity plus 1c. However, the wave is so stretched that the energy associated is nearly equal to 0. When you take a quick snapshot of this scenario, you see that an object's light encompasses the entire universe in at least 1 or more reference frames. There is a bell curve associated with the energy and distance from material's center. It is interesting to compare this to Heisenberg's uncertainty principle because the bell curve shape associated with position and momentum seems to be related to this phenomenon. Our curve is directly relating the now standing energy with distance from center. This implies that your energy exists in all moments of space and time in at least one or more relative frames of motion. In other words, your light, and therefore influence, exist at the edge of the universe, but is most dominant and influential in your own relative frame of motion, in the physical space in which it resides. Space prepares itself before matter shines. Every particle or wave of light exists at all places and moments in time in at least one or more reference frames. In other words, everything is somewhat everywhere, but your energy is strongest in your own frame. Now let's take another journey on a UFO. While doing so, we would be jumping from one relativistic frame to another. You would see the energy of the earthly light beam slowly decrease as your velocity increased. You would reach a point where your light is so stretched it becomes almost unnoticeable. Now let's move backwards along this trip. Assume you are accelerating at light speed from infinite velocity, and instead of accelerating away from the Earth, you accelerate towards it. The wave of the light you would originally see would be extended to infinity, and then slowly the light would then fabricate into the light of the earthly frame once the velocity of the bodies is the same. You never physically move towards the Earth, you simply accelerate towards it until the velocity differences are the same. What you would see is a shift from long waves to short. What's interesting is that these particles already exist as long waves at the edge of the universe, and that it takes a certain amount of time for the particle of the source's frame to arrive. When considering physical space now, it would take an infinite amount of time for the light as seen from the earthly observer to arrive at the edge of the universe, whereas in the subject moving at infinite velocity, it is already there and takes no time. This shows the potential for building a device that may be able to detect the future. Space preparation conclusion. A particle or wave exists in all moments in space and time in at least one or more relative frames of motion. Space must first be prepared from long waves to short as particles or photons move through space, or rather manifest. This space preparation can be sensed and therefore measured and computed. Although current technology may not yet exist to capture this in motion, it is a real possibility and the concept of future imaging does exist.